Well, unfortunately, we're not done troubleshooting this debris. We also need to get motion blur working. So before we hit Karma, we need to create a render geometry settings, and we need to turn on motion blur for these guys, essentially. So let's go drag over our debris under the primitives /**, and we have motion blur. Set that so that it's enabled for this object. Restart, nothing happens. Okay, so what else can we try? There's this instance velocity, so we could try setting that. We have no velocity blur, velocity or acceleration. And so we could try acceleration, and there we go, that works. But I do want to let you guys know that I also added a trail stop, sent to central distance. It's matching based off of the name, so it knows which piece to calculate. And just for safety measures, I promoted this from a point to a primitive so that we have two vectors right here for both point and prim. So now that we have that, this actually works pretty well. And after a few shader tweaks with the shockwave and our pyro plume, we have something that's more subtle. On the shockwave, there's nothing special to that. You just turn down the density in the shader. And I also found to get this hovering closer towards the ground, it's useful to take the shockwave geo network and translate that down by about 0.15. It was just hovering above the ground a bit too much due to the coarse resolution, so you can kind of trick it by doing that. And with the subtle shading, you really can't tell the difference. Also, it's worth mentioning that I turned up that fill lights so that we're hovering just above black in these areas that are being filled. Usually with the fill light, again, to keep your dynamic range, you want to hover above black a little bit, but you don't want things clipping down. So we actually could turn this up even more for areas like this, but I think this will do just fine for what we need. So now we can check off the shading of the shockwave and that fill light, leaving us with color fields, camera shake, and I can talk about how to bring multiple explosions into this scene. So with color fields, there are a few different ways to go about this. My favorite way is to add in an additional field, to rasterize an additional source volume that stores in the color, and then we'll move that source volume around in our simulation by advecting it with velocity. And so your first instinct might be to use a attribute noise and maybe try to do a noise vector. And from here, maybe you can define two kinds of color and have a noise that does that. However, I don't like that approach because it only allows you to interpolate between two colors. What's much more detailed and better is if we can rely on the complexity of a texture map and then project the information of that texture map onto whatever we're trying to rasterize. So here's what I mean. Let's start off by making a sphere. I like setting this sphere to polygon, change the frequency to something like 20 or 30, set the input in right here so that it goes by the bounds, UV project, and specifically we want it to do not a orthographic, but a polar projection like that. Initialize to YZ so that it's facing upwards like so. Then scale it up a tad bit from here. So we go like that. Once we have that, let's now go ahead and use an attribute from map. And we will find a texture which correlates with the colors we want to create. For texturing the smoke, we have this image right here that correlates with the texture map used on our terrain. I add in some extra contrast with some curves so that it pulls out additional data more clearly. The idea with the smoke and the texture of that, or the colors of that, is you want to have differences in color exaggerated a little bit. So what we do is we basically add in that contrast with one map. I then take another texture map, which I found at Texture Haven, and I paint some areas with the other ground texture. It doesn't have to match. And then I do that one more time with another texture map. And then after that, I use our original image as a soft light to start blending in those colors. Now in the process, it's going to saturate things a bit. So at the very end, I desaturate a little bit and we end up with this. So before, after. You might want to also consider brightening this up or darkening it a little bit, but for the most part, I think this will work just fine. The main thing though is that your colors are somewhat of the same tone, but there is a lot of differences in those colors. Because if you have all the colors about the same, you're not going to notice much of a difference. It's just going to blur out. But if we have areas that are bright next to areas that are kind of the darker red, that will add in a lot of detail. Okay, so now that we have this texture map, we're going to apply that to the sphere and then use a ray sop to project that onto any source that's going to be responsible for density. Once we bring that in with the attribute from map, go ahead and set the source color space to linear. By default, it's going to try to apply an sRGB correction, but linear is what we want on that. And then with the export attribute, we want to set that to CD. And I believe that's all we need. So now that we have all this going on, let's go ahead and middle mouse, we have color, and we're going to use a ray sop to project that onto anything, again, that's going to be creating density in our simulation. On the ray sop, the first input, the ray points, is going to be whatever the original source points are. And the second input, the collision primitives, are going to be the sphere we just made. Now, if you go here, turn off the show guide geometry, turn off transform points, set it to minimum distance as points, and now, as we can see, we have successfully transferred color onto that which we want to rasterize. We're going to use CD with the volume rasterize attribute node. And in the process of doing that, we should see that we now have a color field. Let's take a volume slice, see what we got. And there we go. Now we end up with color. So that's pretty much it. Let's go down here, normalize by clamped coverage, turn off the density coverage attributes right there. And we can turn down the voxel and particle size so that it's not super big. So maybe about 0.2 is pretty good, particle scale 0.5. Just adjust this until we have something that's looking pretty good and covers most of what we need. I found that a value of 0.1 in this case worked pretty well. We're going to then use a merge and bring that together with what we had here when we rasterized fuel. So better yet, actually, we use fuel to dictate density and everything like that down here. Let's go ahead and not merge that over here and instead just use a null, and we'll call this our out color combustion fields. And then we can just do a object merge and merge it in with everything else when we go to cache this out. So that's pretty much all there is to it on the SOP level. In the next video, let's take a look at how to advect these values inside of DOPS and then get it working within our shader.